Our mitigation sites tend to be quite diverse, as I mentioned, anywhere from the downtown San Jose along the Guadalupe River to the foothills above Anderson Reservoir and Coyote Ridge, which is a highly sensitive area with a lot of endangered species. Our first detections for Phytophthora occurred in 2014. We have a project that's a mitigation resulting from the seismic retrofit to one of the largest dams in the county, Anderson Reservoir. And a mitigation commitment associated with that project is to create a new population of a federally endangered chaparral shrub that is endemic to Santa Clara County and only grows on serpentine soils, Coyote Ceanothus or Ceanothus ferresi. There's only 3 populations known in the whole world, and they're all located in our county. So our mitigation commitment was to create a new population of this species, and unfortunately in the pilot project for this, we discovered that our entire pilot project was infected with Phytophthora cactorum. So I'm going to use Coyote Ceanothus as sort of the case study today. It really is representative of the wide variety of issues and challenges that we face in all of our mitigation sites, whether they're located on the valley floor or up in the upper watershed. So just a brief 3-year history of this particular project. We installed our first container plants in pristine habitat in early 2014. And while initially the plants did very well, within, I would say, 4 months, they started showing signs of rapid decline and drought-like symptoms. We were able to connect with Ted and Liz of Phytosphere Research, and they documented a pretty universal contamination by Phytophthora cactorum of our planted areas and all of our Ceanothus seedlings. So then we moved into the remediation phase, this being a very sensitive site. We wanted to try and contain as quickly as possible this infection. And through the use of solarization, that's how we've been, for the most part, addressing the issue there. And since then, we've moved to direct seeding of Coyote Ceanothus using seed collected from the adjacent Anderson Reservoir population. And then this year, we've not only planted seed, but we've actually cautiously gone back to the use of container stock. And those are plants, first they're grown and then they're planted with very strict phytosanitary procedures. Remediation is both expensive and tedious. Originally, our solarization costs were about $280 per planting basin. That doesn't include maintenance, and I think now a more accurate and recent calculation is about $896 per planting basin just to remediate this issue. The use of solarization has been pretty effective because we do have sites that receive a lot of solar radiation. It's a hot, pretty dry climate on the east side of the valley here. However, some of the shady areas, similar to what SFPUC has been finding, we haven't been completely successful at eradicating the pathogen. So in what we're moving towards now in shady areas like this particular project, but also similar to many of our creekside restoration sites that are also very shady, is we're investigating the use of a heat auger. And the concept is very similar to what SFPUC has been working on, except they're using a vehicle of steam and we're using a vehicle of dry heat. So this is a prototype that was developed by our field operations unit led by Chad Grande here. So he developed this unit and then our welders happily said, great, we'll build this really cool looking strange contraption, which is actually located right outside the building here. And if you'd like to see it specifically, there's going to be a demonstration at 10:30. Chad will be here to explain in more detail how this works. But quickly, what I'll say is that the reason we decided to go with heat instead of steam is that our staff felt like it would be safer to use heat in the case of a potential accident. And also, it's a more contained unit. So this runs off a 5,000 watt generator with a built-in air compressor, and it's mounted on this bobcat, and it has an 18-inch auger which goes into a 20-inch metal cylinder or sleeve. And then the air is compressed into this area here, there's 4 1,000-watt heating elements that compress hot air into that tube and then push it down into the base where there's a series of holes drilled through the metal. And the heat starts here. Meanwhile, the auger is augering the soil up into this sleeve, and then the soil is being heated at the same time. So it will achieve temperatures of up to 900 degrees. We haven't actually tried it yet. We're still waiting for the generator to arrive. It's on order. But we're really excited about the use of this tool and its ability to navigate some of our very tight, difficult to access mitigation sites. It took about 9 months for us to design it and get to this point where it's almost ready to be tested. And the cost of it was about $7,000 in labor and $5,000 in parts. So it's actually fairly reasonable in the costs. So on this and other projects, this is the district's response over the last 3 years to being faced with a huge issue of Phytophthora contamination in our mitigation sites. We've worked hard internally and with the regional working group to develop a series of BMPs and contract specifications. This includes everything from BMPs that govern our basic operations and maintenance activities in a wide variety of different sites and projects, to specific work in sites that contain sensitive species and sites that we know have documented Phytophthora contamination. We also have nursery specifications for how plants can be grown clean, and then also planting methods where those plants can be put in the ground using phytosanitary measures. Similar to SFPUC, we use a direct seeding whenever possible. We are cautiously, as I mentioned, using container stock with our BMP compliant nurseries, so they're grown pretty rigorous set of phytosanitary standards. We participate in regional working groups such as this one, and that's been incredibly beneficial to us to have that ability to kind of collaborate with people and, figure out together how we're going to go forward and address this really difficult issue. And it also involves a lot of education of our stakeholders, our project partners, our regulatory staff, internally, contractors that we work with, our nurseries that we have relationships with, and additional testing and remediation where it's needed. It's been a pretty intense 3 years. The discovery of multiple failing mitigation sites and over 50 Phytophthora taxa have been documented on those sites. And that's due to the work by Phytosphere Research, Ted and Liz, as well as the Rizzo lab at UC Davis have helped us quite a bit with understanding the extent of the contamination we have and then how to address that. So now back to something more positive. This is the first year after we direct seeded Coyote Ceanothus. These are the plants 1 year later. We had pretty close to 100% germination in our basins, which was great. Since then, some of the areas are doing really well, others not so well. We're noticing quite variability among different basins and different microsites where we're doing our test basins. But this variability is really what we would expect with a direct seeding effort, and that's part of the learning process. So we're still quite excited about the progress we've made and where we're at with this. This year we went to the use of container plants as well as direct seeding, and we are very, very happy with the result of that. And I can tell you that when plants are grown with the phytosanitary BMPs and the clean standards, the product that we have gotten is absolutely noticeably different. The plants are more rigorous, they have really good root development, dark green, glossy leaves. They just look really, really healthy. So we're quite happy with the changes. Even though it's an increase in standards, it costs a little more, it's harder to grow plants in this method. The product that we get is noticeably better.